Hello students, let us review nuclear physics of class 12. It is known that radius of nucleus is of the order of 10 to the power of minus 15 meters. Say hydrogen atom is having 1.1 into 10 to the power of minus 15 atoms between meters. This is the minimum lowest nucleus, that of hydrogen. It is denoted as RO, as RH also we can denote. So nucleus is R into A to the power of 1 by 3. What is A? A is mass number. So from which we can estimate nucleus of any item in the periodic table. You have to take the mass number to the power of 1 by 3 multiplied by 1.1 into 10 to the power of minus 15. So this is the nucleus. So see, we are studying about nucleus. This is nuclear physics. So there is nuclear density, you have mass per unit volume. Mass is, atomic number with mass number into each multiplication. So total mass divided by 4/3 by RO cube for hydrogen. This is for hydrogen. 1 AMU is a atomic mass unit. Is defined as 1/12 of carbon nucleus. Atomic mass unit defined as 1/12 of carbon nucleus. 1.66 into 10 to the power minus 27 kg. So 1 mu, if you convert into mc square, Newton's formula, EmC square, and if you divide by 1.6 10 to the power minus 19 in electron volts, this is joules, and you have to convert joule to an electron volt. I have to divide it by 1.6 in 10 to the power minus 19. So it's around 930 million electron volts. It is 931 million electron volts is 1 AMU. If you see here, 1 AMU is 1.66 10 to the power minus 27. Similarly, 1 proton is 1.673. It is 1.675 1 neutron. Electron 9.1 into 10 to the power minus 31. So this small difference. This is 1.6 10 to the power minus 27, 673, 675. Small difference will lead to, you see, is a proton. What is proton? 673. 938 million electron volts. Similarly, for a neutron, 675 is 939.5 million electron volts, as 1 mu is equal to 931 million electron volts. So they are all very nearby. 66, 673, 675. If you take electron mass, 9.1, 9.1 means how much it is? Around 0.551 million electron volts. So this is the mass number, this is the mass we compared to AMU. This is the electron, these are all nucleons. Electron, proton, neutron are nucleons and their mass numbers. Here they have defined neutrino and antineutrino mass is 0. Neutrino and antineutrino mass is 0. So this is the, we go to the extent of 0.00, 1.673, so that to distinguish between proton, AMU, neutron and electron. So this is the 931 million electron volts is 1 AMU. Is atomic mass unit. This is a standard unit. Now we have to, in nucleus itself we have isotopes where atomic number is same but mass number is different. We have isobars where mass number is same but atomic number is different. We have isotones where number of neutrons is same. Suppose hydrogen 3, 1, there are 2 neutrons here, 1 proton. So here again helium 4, 2 neutrons. They are called isotones. Now isomers. You have butane and isobutane. They have C10, C4H10. This is also C4H10, but they have different configuration and different properties. So like that we have in the nucleus itself, the arrangement of atoms itself make it different types. So let us see the stability of nucleus. If you see this drawing, it is a hydrogen, helium, other things are here. Then we have iron, nickel at this point, and we have further uranium at this point. It is said that at the place of iron, nickel, This point is most stable point of the nucleus. This is the most stable point. So that means as you go to this point, its stability increases. As you come to this point, the stability increases. So higher elements try to come to this zone, from this to this. Lower elements try to come. That is why hydrogen, they get fused to become a bigger atomic number. Similarly, U-235, 238, they get diffused, they get fission, separated to come to this atomic number zone. So this is fission zone, this is fusion zone to come to a most stable zone. So a 240, if atomic number is there, then it has 7.6 million electron volts per nucleon, its binding energy here. But iron nickel is having around 8.5 million electron volt per nucleon. So this is more stable. More energy is holding the atom together, the nucleus together. So this will try to come to this and release this energy. So what is packing fraction? Packing fraction is this mass defect. What is this called? Mass minus mass number is the mass defect by mass number per mass number into 10 to the power 4. This is the packing. This shows what is the extent, how much it is tightly packed. Per mass number, how much it is tightly packed. This is a mass defect. Defect means the energy holding the nucleons together. By mass from 10 to the power 4 is defined as packing fraction, which will give its the susceptibility for stability or destability. So now what are these nuclear forces? Whatever we are talking here, short range forces between nucleons. They are of non-conservative nature. They are not like electrical. This is not plus minus attraction. This is not gravitational attraction. This is not magnetic attraction, magnetic poles attraction or repulsion. These are all short range between nucleons, irrespective of charge, independent of charge, independent of mass. They are the force. How this force has evolved? This force has evolved because mesons are being exchanged for forces. Mesons are being exchanged for, what are these mesons? So neutron emits out pi minus particle and becomes a proton, whereas proton emits out pi plus particle and becomes a neutron. These pi minus and pi plus are termed as mesons. So proton will be converting to neutron, neutron will be converting to proton, and that way these conversions, they all get fixed. So what are there in nucleus? We have protons and neutrons only. Okay, so they get converted each other and evolve these mesons and try to maintain the forces. So this is the reason for nuclear forces, plus of course binding energy. Binding energy also helping in nuclear stabilization. We have seen nuclear force is around 100 times than electric force, which is around 10 to the 38 times on gravitational force. You can see even the constants are also almost, that is gravitational constant. We have 1 by 4 pi epsilon naught is 9 to 10 to the power of 9. It is 9 to 10 to the power of 9. Gravitational constant is very less. So like that we can compare the forces also. Now what is this mass defect? I have told about mass defect here, mass defect here. Mass defect is, we have a nuclear number, Z is atomic number, into mass of proton, plus A minus Z into mass of neutron, plus Z into mass of electron. All the three will come. So if this is Z and A are its number, Z number of protons, Z number of electrons. That means what? Mass of proton plus mass of electron into Z, plus this many number of neutrons. This should be its theoretical weight, but the actual weight will be less. M actually will be less. The difference is called mass defect. This mass defect is converted to mc square. This mass defect is converted to mc square, and the energy is holding the nucleus. So mass defect mc square by per nucleon. Nucleon means A is number of nuclear material, that protons plus neutron together is A. So per nucleon, this is the binding energy which we are talking here. Binding energy per nucleon. So if it is P is more, it is more stable. This 0.5 is more stable. Items with odd protons and odd neutrons are more stable. It's given like that. So lower mass density will go for fusion, higher mass numbers will go for fission. they attain more stable forms from their present unstable forms. Now let us understand radioactivity. Radioactivity is basically coming from nucleus. It is not a outer orbital phenomena. It is not s orbital, p orbital, d orbital, or 1, 2, 3 orbits. No, it is from nucleus. So disintegration of heavy nuclei into smaller fractions is called radioactivity. They emit alpha, suppose plutonium, uranium, all these things emit alpha, beta, gamma rays. Alpha is what? Alpha is nothing but helium ions. Beta is electrons, either positive or negative, both are there. And gamma is pure form of energy. Okay. Gamma is pure form of energy release. So beta is either plus or minus. Either it can, here I have taken as beta minus, so it is getting attracted to the positive plate of electric charge. But if it is minus, if it is plus, it will come this side. So alpha is automatically, alpha is positive helium, helium plus plus, so it will get attracted towards negative. So gamma rays are purely energy, they don't have any charge. This is the effect of electric field. Beta is normally we take as positive, but sometimes it comes as negative also. So this radioactivity is what is number of atoms getting disintegrated per unit time. dN by dt is number of atoms getting disintegrated per unit time and number of atoms emitting this and becoming a other stable atom. This is directly proportional to the number of atoms present in the system, which are non-disintegrated so far. What does this equation says? Suppose initially 100 are there. So dN by dt is proportional to 100. Then after some time 50 are left out. 50 are got disintegrated. Then dN by dt proportional to 50 only. So it is proportional to the quantity available. Fresh atoms available for disintegration. So the rate of is proportional to that. So what is this proportionality constant? It is given a name as lambda. It is a decay constant. Lambda is decay constant. So dN by dt is equal to minus lambda n. If I integrate, dN by n is log n, lambda dt is lambda t. So n is equal to n0 into e to the power minus lambda t. n0 is initial number. N is present number. So whatever number left out, this is number n, which is main cause for the rate of disintegration. So present n is NO into e to the power minus lambda t. If n is half of NO, we call it as half cycle. If NO becomes half of NO, and so half of the atoms have disintegrated. So when I put a half, then I'm getting time is equal to log 2 by lambda. Log 2 by lambda. There is another term called average time, which is called 1 by lambda. Log 2 is 0.693 lambda, but average is 1 by lambda. So average is around 1.44 times of t half cycle. So sometimes problems will come on average time, sometimes on half cycle. Suppose if there are n half cycles. So how many electrons are left, how many atoms are left out? So NO by 2 to the power of n. Because each time, first half cycle NO by 2, second half cycle NO by 2 into 1 by 2, like that it will comes to NO by 2 to the power of n, are the left out fresh atoms after n half cycles. Okay, so another term defined as activity. Activity is defined as the minus dN by dt is defined as activity. This is the activity going on. So much of at this point of time, at so many atoms are getting disintegrated. It is nothing but lambda n. Activity is nothing but lambda n. So R is also equal to R0 into e to the power minus lambda t, because lambda n is equal to n0 into e to the power minus lambda t. n0 into e to the power minus lambda t is nothing but R0. So R0 into e to the power minus e to the power lambda t will be there. R0 is so lambda n, when I convert R to R0 e to the power minus lambda t. So both are valid. N is equal to n0 e to the power lambda t, number of atoms getting disintegrated. R is the activity, radioactivity prevailing at that time is also So now let us see this disintegration part. See here, I'm just showing one disintegration part. Carbon 14 is there. Carbon 14 is having how many? 6 protons and 8 neutrons. So there is a disbalance. Protons and neutron disbalance. So one of the neutron will convert to proton. So 8 neutron, when neutron becomes proton, so here what is coming out? E is coming out, minus. Electron is coming out from the nucleus. When electron is coming out from the nucleus, neutron becomes proton. Then how many left out? 7 neutrons and 7 protons. They got balanced. 1 electron left out. So along with that, anti-neutrino is also developed. What is this anti-neutrino? Anti-neutrino, this is anti-neutrino. These are also evolved. No mass, no mass, but energy is there. Anti-neutrino is evolved. So the carbon atom became nitrogen atom. This is called beta minus evolution. So I told you beta need not be always plus. Beta can be minus also. So here electron is evolved. So in the other case you take same carbon 14, in place of carbon 14 we have carbon 10. 6 protons and 4 neutrons. See what is carbon 14, carbon 10? Protons are same. That means atomic number is same but mass number is different. So atomic number is simple isotope. So when we here protons are more, neutrons are less. So one proton becomes neutron. Here B plus. So positive E plus is evolved. E plus we call it as positron. We don't call it as proton. We call it as positron or beta plus. So 5 protons, 5 neutrons. It becomes again boron. Carbon becoming boron. So basically from the atomic number it gets 6, it comes down to 5. 6 increased to 7. So from this 5 protons we get the atomic number is for boron. So it evolved neutrino plus positron. This is B plus evolution. So we can have E minus evolution with electron evolution from nucleus, or we have positron evolution from nucleus. So this is the system. You can same thing is explained here. You see here, suppose the incident photon is on nucleus. So it can evolve an electron, it can evolve a positron. It can come both B minus or B plus. So one neutron is beta decay of a neutron. A neutron has come, neutron has converted to proton. Neutron has converted to proton. So one charge has increased here. So it automatically evolves one electron and one anti-neutrino. This is anti-neutrino. So this is the equation how a neutron is converting into other. These are the nuclear phenomena that is happening. So it is defined that same thing is here. Is a fusion action. 2 hydrogen atoms coming and forming neutrino and comes to H2. Then again one more hydrogen is getting added. Again gamma rays are released here, making helium-3. Then helium-3, another helium-3 comes to the same cycle. It is repeated here. So both helium-3 become helium-4 and one hydrogen. This one proton is evolved. So energy around 26.7 million electron volt is released. If you see the equation, this is the same fusion we are talking here. 3 hydrogen nascent hydrogen atoms. This is what is happening in sun. Sun is what is happening, all hydrogen converting into helium. So 3 hydrogen nascent atoms. Finally 3 became 2 here plus 1 3. Became helium plus again one hydrogen atom plus neutron. This is one neutron is evolved and 21.6 million electron volts is energy released. So what temperature it comes to? 10 to the power 7 Kelvin and 10 to the power 6 atmospheric pressures. So you can imagine how much Nagasaki and Hiroshima got affected with these temperatures, pressures and a lot of gamma radiation. Gamma radiation is very dangerous for our body. We cannot get exposed, but in this nuclear, so many atoms getting fused and releasing, and this is one action. We are releasing 21.6 million electron volts. Like that, millions of atoms get disintegrate, get fused to release huge energy. So you can imagine gamma radiation plus temperature plus pressure. This is the energy in a atom, nucleus. So it is there is a term given Curie because the radioactivity has been discovered by Madame Curie brothers, Madame Curie family. So 1 Curie is equal to 3.7 into 10 to the power of 10 decays per second. It's a bigger unit, so they have defined a smaller unit, Rutherford, is 10 to the power of 6 decays per second. So into 10 to the power of 4 is 3.7 into 10 to the power of 10. So Rutherford is 10 to the power of 6 decays per second. Sometimes this is what is that? This is nothing but the activity. What is activity? dN by dt, decays per second. So what is given? This is R, activity. So number of atoms per second getting disintegrated. Suppose you take a U-235. We have talked of fusion here. Now we are talking of fission. U-235. If small moving neutron gets added to U-235, then what happens? It converts into beryllium and krypton. So these are 56 and 36. You can see here. So this is the range. U-235 will come to 56 and 36. This range of barium material to get stabilization. So, but 85% only converts to this. 85% converts to this, and they release 3 neutrons and a lot of energy. But balance 15%, these neutrons are slowed down by heavy water. In reactor, there is a heavy water. This heavy water slows down this highly speed neutron. They become slow neutrons. Then 2 neutrons will be absorbed. 1 neutron will be again given to the U-235. Again, this reaction starts. So that's why this chain reaction continues to go on and releases heat energy. If balance 50, this is 85%. 15% will directly convert to gamma rays. Converts to gamma rays directly. Okay, a simple nuclear power plant is these are the cadmium rods to absorb neutron. Suppose I don't want any radioactivity. I want to stop the unit. So the cadmium rods will go into the system and all neutrons will be absorbed. So there is no neutron available for the system to disintegrate. So it will stabilize. Suppose I want more nuclear activity, I want more power, so it will be lifted up. So this is heavy water for reducing the speed and also taking the heat from this nuclear reactor. This heavy water will go to a boiler, and in the boiler it will convert into steam. Water will be converted into steam. That steam is used. This is boiler. This heavy water will make the boiler steam. This steam will be used for power generation. Okay, this steam will be used for turbine generator and power generation. So fuel rods, heavy water. It can be heavy water, it can be graphite, it can be beryllium oxide, whatever feasibility can be used. This is a simple nuclear power plant principle. So in this reaction, 2.5 neutrons are released, 1.5 absorbed, and 1 for chain reaction. So then thermonuclear reactions, protons for fusion and neutrons for fission. See, these are the protons. They cause new fusion. And these are neutrons for fission. So it is standard. For protons are used for fusion and neutrons are used for fission. So one small problem, let us say. Suppose from 60% to 7.5%, to decay from 60% material to 7.5% material, how much is the time required? So it is given 0.075, 7.5% means 0.075 N0 is equal to N0 into half cycle, half to the power of N. How many half cycles it is taking to becoming 0.075 is the N. This is N left out. This is N0 into 1 by 2 whole to the power of N. So we get around 3.77 half. Suppose if I take logarithm here, it becomes N1 log N0 into N1 log half. So N0 will get cancelled. So log 0.075 is equal to N1 into log 0.5. So when log 0.075 divided by log 0.5 gives me my N1. Similarly, log 0.6 divided by log 0.5 gives me N2 because 60%. So it is 0.6 NO are left out. Okay, 60% left over. This is all left. 60% left over. So 0.60 is the N. So when I minus it, I got 3 half cycles. So from 60%, it will take another 3 half cycles to come to 7.5%. One half cycle, approximately 30, 50, 7.5. It is like that. 30, 50, 15, 7.5, half. So that way it goes on. So it takes 3 half cycles. This AMU we have discussed, this we have discussed. So cobalt, if you see the cobalt 2760, here we got electron is emitted. Beta minus means electron. So here the gamma emission also is there, the energy. Again gamma emission 1.17 million electron volt in the first reaction. Again 1.33 million electron volt. Then it became 28 nickel. So cobalt became nickel. We are given nickel and iron are most stable forms of elements. So it has become nickel. So here what happened? Neutron has converted to proton to reduce the gap. So 28, here 2 is the gap between neutrons. 60 minus 28 is 32. 32. Here 60 minus 27 is 33. So one neutron converted to proton.